Welcome to this intriguing exploration of viruses. Today we'll unravel the paradox of viruses. They are neither truly alive nor completely lifeless, yet they possess the power to disrupt our bodies profoundly. Cell structure. Let's start by examining a cell. Imagine it as a bustling factory, filled with essential components called organelles. These organelles include mitochondria, which function as the energy factories, and ribosomes, the protein production hubs. At the center lies the nucleus, the control center of the cell. Now, here's where viruses differ significantly. Viruses lack these cellular structures entirely. They are not cells. Instead, they are merely genetic blueprints encased in a protein shell. Without the machinery of a living cell, they cannot replicate or produce energy independently. How viruses operate. When a virus encounters a cell, it's like a key fitting into a lock. The virus inserts a spike protein into the cell, triggering a series of reactions that allow it to hijack the cell's machinery. It exploits the cell's resources, replicating itself until the cell ultimately bursts, an act of destruction that characterizes viruses as parasitic entities. Evading the immune system. Let's dive into how viruses can evade our immune defenses. There are two main types: lytic viruses, which destroy the cell membrane during replication, and latent viruses, which may initially cause destruction but later integrate their genetic material into the host's DNA, lying dormant. They can reactivate later, often triggered by stress or weakened immunity. Think of herpes simplex or HIV, which exemplifies this behavior. Where do viruses come from? Now, the origins of viruses are shrouded in mystery. There are several theories. Virus first hypothesis suggests that viruses existed before cellular life. Reduction theory posits that they are remnants of once living cells that lost their independence. Giant virus theory proposes that some complex viruses may represent a fourth domain of life. Evolutionary contribution theory involves horizontal gene transfer, suggesting that viruses played a role in evolution. About 8% of our genes have viral components. I believe that viruses may also serve a crucial purpose in strengthening our immune systems. We have two types of immunity: innate, which we inherit, and acquired, which develops over time, often in response to viruses. In fact, exposure to viruses can enhance our immune resilience, similar to how exercise builds physical strength. The role of vitamin D. Let's discuss an essential nutrient. Vitamin D. Many people don't realize that there are two systems for vitamin D in our bodies. One regulates calcium and bone health, while the other supports various non-calcium functions, particularly immune function. The vitamin D circulating in our blood is largely inactive, primarily serving bone health. For a robust immune response, we require a significant daily intake, around 10,000 IU, which can be sourced from sun exposure or supplements. Zinc and immune function. Zinc also plays a vital role in our immune health. It helps counteract viral replication and is crucial for maintaining the balance of our immune response. In addition, selenium, a mineral found in Brazil nuts, can help reactivate immune cells compromised by viruses like HIV. Stress and immune response. As we age, our immune systems may weaken due to stress, which elevates cortisol levels and further suppresses immune function. Chronic stress can trigger latent viruses to reactivate, leading to illness. Strengthening immunity. To combat viruses effectively, we must strengthen our immune system. Key strategies include: vitamin D, essential for modulation of immune function. Zinc, supports immune defense and counters viral reproduction. Vitamin C, found abundantly in foods like raw sauerkraut. Adequate sleep. Aim for 7 to 8 hours nightly. Stress reduction. Engage in physical activity, nature walks, or mindfulness. Garlic and elderberry. Both have antiviral properties. Intermittent fasting and magnesium. Both boost immune cell activity. Conclusion. Viruses, when outside our cells, are powerless. They thrive only when they infiltrate our bodies. Understanding how they interact with our immune systems can help us build resilience against them. By adopting a healthy lifestyle and focusing on nutrition, we can equip ourselves to fight back, turning our attention to strengthening our immune system rather than merely suppressing viral activity. Remember, viruses are not invincible. They are a part of our intricate biological landscape. Embrace the knowledge, apply it to your life, and empower your immune system,